Okay, so question one: metal ball has been falling towards Earth for 3.5 seconds from rest. What is its acceleration? You won't be able to work out the precise acceleration, but it'll be very, very close to 9.81, the standard acceleration of free fall on planet Earth. It won't be quite 9.81 because there will be some air resistance. However, the air resistance will be relatively small. As things get faster, then its acceleration will reduce because the air resistance will get larger, and so eventually, so it will get larger and larger, and therefore the resultant force will be lower and lower. But so if we imagine that's the weight, and that's the air resistance there. As it falls, the air resistance gets larger and larger, and so the resultant force will be equal to the weight minus the air resistance. Eventually, these two will balance out, and the force will be zero, which means the acceleration, because it's force divided by mass, will also be zero. However, after 3.5 seconds, it's going to not really have got to that stage, especially if it's a metal ball, because it's going to be able to go through the air resistance. Not going to have that much of an effect. So acceleration is going to be essentially 9.81, and you might get some points for saying it's going to be nearly 9.81. Okay. What is its velocity? Well, we assume the acceleration is about 9.81, so we would say that velocity is equal to initial velocity plus AT. So how did I know to use that one? Well, I've got the initial velocity because it's 0 from rest. I've got time. I got acceleration, so the only thing I don't have is displacement, and so I use the equation that doesn't have displacement, and I don't need it, so that's the one I use. It's nicely rearranged into the right way as well. So U is 0, so it's going to be plus 9.81 times 3.5, which is roughly, it is 34.3 meters per second, I believe. I'm not sure if I rounded that up or not. I'm just going by my notes here. Okay, how far has it fallen? Now we do want a different equation, don't we? We want to use, we can now use any equation because we've got every variable apart from S. So I think probably the easiest one to use would be S is equal to UT plus half AT squared. And the reason for that is because that's going to cancel out because U is equal to 0. You're going to get the half times 9.81 times the 3.5 squared. So then you could, and so in that case, you would use this equation even if we hadn't done B yet, and if you put that into your calculator, you should get 60.1 meters. So half times 9.81 times 3.5 squared, you should get about 60.1 meters. Okay, let's have a look at what else we got here. It takes the squirrel 2.4 seconds to react when it hears a coconut. When it hears the coconut to fall. Again, bit of strange grammar there. Will it escape being hit by the coconut? Well, in other words, is the coconut going to fall in less than 2.4 seconds? Let's find out. So we know that U is equal to 0 because it's in free fall. It's about to start falling in free fall. We know S is equal to 30 meters. I should have done this let's do this in the right order. That's probably good practice. So we'll spell the word suvat. We don't know what V is equal to. We know A is equal to 9.81. We don't know what T is equal to, but it's T that we want to know. So we want the equation that doesn't have V in it. So see if you can find the right equation. Okay, so you should have found it is this one again, S equals UT plus half AT squared, and you'll find that that's quite often the one that we want to use when we do questions on free fall. But let's put that in then. So, so we got S is equal to, and we'll leave out the UT. It's going to cancel out anyway. Half, or we can say H, whatever. H is equal to half GT squared. So I've used G instead of A. I'm going to rearrange that. So T is equal to 2g. I'm going to put h this time instead of s, and I'm going to square root that, and that will give me the answer for time. So that would be 2 times 9.81 times 30, and we want to know, and then square root it, and we want to know, is that greater or less than 2.4 seconds? Will the squirrel have enough time to get away from the coconut? Okay, so those of you who may have noticed the deliberate mistake there, or I've rearranged it incorrectly, so I should have divided by g over there, so that goes over there, and you end up with this. So the time it would take would be 2.47 seconds. So the squirrel will get away. It'll have just enough time to get away, I suppose, 0.07 seconds to get away. You could have done this in a different way, and that is by using the time and calculating the distance that the coconut would have fallen in that time. And you would have found that it would have fallen 28.3 meters. Okay, let's have a look at the next one. I think I'll stop that video there actually, and we'll just save this as for question 1 and 2.